Hello everyone! Today we're going to do another electronics video. Today's electronics video we're going to talk about how to use a multimeter and what it is. We also will do a little bit about breadboards and just use it as an example to show how these guys work and just how handy they are because you don't have to solder your circuitry together. Now, none of these name brands or not name brands or whatever you want to call them, none of these companies, there we go, are sponsoring this video. So I might have to try to figure out how that affiliate link thing works on Amazon. That would be neat to be able to do that. The multimeter, that's pretty straightforward. We're going to talk about that. But before I get into that, I want to talk about this kit. Kudos go to Jesse, a guy I work with. He's the one that found this. This is on Amazon. And if I can figure out that affiliate link thing, it might be in the description as well. Anyway, though, it's a beginner's kit that comes with push buttons and speakers and capacitors, a breadboard, and the power supply, which is the thing that interested me the most. So you can see it comes with these nice little things. It also comes with various jumper wires and male to female wires and all sorts of different things. There are packages of resistors that come in there as I throw them across the room. And the only thing that you'll probably see in this video that doesn't come in there are these little alligator clips. I do that so that I can film things and not have to be as precise with the way my hands are holding on to all the little leads and things like that. All right, so anyway, that's the kit. I should talk a little bit about this power supply. This power supply takes USB in. It also has this barrel jack. The barrel jack I haven't actually figured out what voltage it is. I'm sorry about that. I can guarantee it's not 5 volts because I bought a barrel adapter here and I thought I was going to be all good to go. And it's at 5 volts, but when I measured the voltages on the little board itself, they were not correct. USB, on the other hand, works great. You can see that we have a 3.3 output as well as a 5 and a ground. So we'll test that. We'll use the USB power with the little cable provided and just a generic cell phone charger. And we will test out that. But let's use something a little bit larger. And that would be a battery. Again, not sponsored. So, all right, we have all of the little toys that we're going to be playing along with, as well as this little resistor here that's a little bent out of shape, but that's the nature of having fun and playing with these things. We will not talk about the color bands today, and that's because we'll do something on resistors in the future where we actually get into more detail about these things. So, the voltmeter itself, or I should say the multimeter, it does allow us to test voltages, amperages, both AC and DC. By the symbols you can see that. Also continuity, as well as capacitance, resistance. This one does hertz, temperatures, a little bit of everything, I guess, here. When you look at the bottom here, you can see there's a common port. This is where the black lead always goes. These leads are for amperage only. You can see that 10 amps will burn this fuse out. That's for your safety. And 500 milliamps for the micro and milliamp readings. Everything else goes through this one. So we're going to do voltage first, so let's start with that. To do that, we need to use some probes. And here they are in all their glory. I have quite a bit of stick out on these probes, and that's because I'll probably use these alligator clips so that I can clip onto things and not have to worry about doing things on camera. However, if you want to do more precise controlling and you don't want to accidentally touch things, by default it came with these little adapters on there which reduce the size of your probe by quite a bit. So we will plug the black into the black, the red into the everything except for amperage one. We'll switch this over to voltage. And the first thing you'll notice is this wavy line, which means we're trying to measure, get rid of the glare if I can, AC, and also the word auto up here. means that it is auto ranging. There we go. If I switch this over to that, now we're on DC, and I'll try to put that somewhere where the glare will not affect it. Black is generally your negative lead, and you can see the negative side of the battery is the bigger one. So let's hook that up and see what happens. We can see that it's at 9.36 volts, which means it is fully charged. If I reverse my leads, now it'll say negative 9.36. So obviously polarity does matter when you're working with DC. So this battery is fully charged. That's good to know. All right, so let's see if we can measure resistance now. I'm going to switch this over to the resistance setting, and you'll notice that on this multimeter, it has an ohm symbol. Well, this is a 1 kilo ohm resistor, and I know that because I looked at this, which means it's 1 kilo ohm. However, as I said, you can use these bands. We'll talk about that in a different video, though. I'm going to hit the select button on my multimeter and try to get things in focus. And you can see now it does kilo ohms and mega ohms. So if I can do this, I'm going to have to stop looking at the camera screen and see if I can get this tracked down without it flying across the room. You can see that it is at 0.990 kilo ohms, which is about 1 kilo ohm. There's always a little bit of tolerance on these things, and this is no different. So we have measured voltage and we've measured resistance. Now that leaves amperage to test, and that's why I'm excited about this little power supply, because amperage is not tested like voltage, where you measure the potential difference between different things. You actually run it in line. So I'd have to connect a probe to this somehow, and then the other one here, because the actual multimeter needs to be in the circuit, in line, in series with the circuit. So before I forget, let's switch this over to microamps, because we will not be testing huge amounts of amperage by any means. We'll switch over to the milliamp. It's warning us that our lead needs to be somewhere else other than where it normally is, which is handy as well. And now let's take a look at our little board here. There's these power rails, and you can see that this rail is 5 volts, and this other one is at 3.3 volts. So various circuits use various amounts of electricity. And just to prove that it's actually doing what it says, let's do that first. So I'm going to hook, I guess, black up to hot, white up to ground in this case. Just like, I guess, wiring your house. So you can see that I have the 3.3 and I have the ground there. So let's connect these to our leads. And this is why alligator clips are wonderful inventions. Not having to be quite as precise with my hands. And we'll plug this in. And then we'll plug this into our cell phone charger. Now, there's nothing to start out with. Ooh, sorry about that. We wanted to test voltage, right? Good practice for me. Stay on task. All right. Anyway, now if I turn this on by pressing this button, we can see that we are on AC, so we're not going to get anything. Switch that over to DC. I'm going to try it again. We're at basically 3.3 volts. Very cool. And if we move this to one of those little 5-volt pins and test it again, now we are at basically 5 volts. It looks like it's 0.04 off from being 5 volts, and I'm sure there's a little bit of internal resistance in the actual circuit. So that's the thing you have to remember, as well as when you're doing designs online, your circuits are going to be using perfect voltage sources, wires that have no resistance and everything else. In the real world, you're going to have things like this, slight discrepancies. So the world's not perfect. All right. Well, now we've shown that the voltages work on this, and we've tested them also on this. Let's get to amperage and wrap up this video. So again, the lead needs to be moved over. We're going to switch over to milliamps. It will warn us that our lead needs to be in the correct spot. And what we're going to do is we're going to make this part of the circuit here. So let's see, what's the best way to do it? This is turned off, so that's good. We'll start with the positive, and we will just plug it into this row. Now remember, for measuring amperage, we need to be in line, or actually in series with the circuit. So I'm going to take one of my connectors here and put it in line with the circuit. And then this one is going to go over to our ground terminal. So the electricity will come, and I'll hold this a little bit closer to the camera. The electricity will start on the positive side because we're using conventional flow. It will come through our resistor, and it still is not all the way to the negative side yet. So it will need to travel through this alligator clip, which will be connected to our voltmeter, or amp meter in this case. And then this will go through the other side of our amp meter into negative. So you can see it is indeed in series. And let's see what our results are. Now, again, you can see that this is on AC. We're going to switch that to DC. And let's do a final check to make sure that we aren't going to fry anything. It's auto ranging. It's on DC. The lead's plugged into the correct place. We are hooked up in series, and we have the ability to turn on the power now. So if we look at this, we can see that it is approximately 5 milliamps. And if you watch the Ohm's Law video, we did do an example with a 1 kilo ohm resistor, and we had about 5 milliamps. So, or let me see, we might have used a 10 volt power supply. So we probably had 10 milliamps, but as you'll remember from that video, the voltage, the amperage, and the resistance are all related to one another. So in this case, since we have approximately 5 volts coming in, we have a 1 kilo ohm resistor, and if you do the math, you have approximately 5 milliamps. So that's all that I had for you in today's video. I hope you found this video enjoyable. Hopefully now you understand a little bit of what to look out for on a multimeter so you don't hurt yourself or hurt the meter. You've seen a handy little kit. At least I think it's pretty handy to do some of this small electronics work with. And we have shown a little bit about voltages, resistances, amperages, things you can do with the probes, making them more exposed and less exposed. So I look forward to seeing you in the next electronics video. And it will be a mixture of doing things in the lab, quote unquote, here, and also doing things on the computer so that you can see in the ideal world what it would do, and then in the lab what actually happens in real life. So we look forward to seeing you in the next video. And if you're still here and you like this content, please do hit that like button. It lets me know to make more of this content. And if you like these videos in general and you want to help the channel get out to a larger audience, please do consider hitting that subscribe button so that more people can find the channel. So that's all that I have for you today, and we look forward to seeing you in the next one.